All right, so we are starting chapter six now. In chapter six, if I go back one step, see if I can go back here. There we go. Chapter six, rational numbers and proportional reason. That's going to come to later a little bit. We aren't going to do a lot of proportional reason, but we'll get there. But we're going to start with rational numbers. So we got to understand some of the things we're going to talk about. We're going to get to ordering them this one in 6.1 because we're just going to talk about what a rational number is. So a rational number is basically a number that can be written as a fraction. Any number over itself, another number. Okay, so before we can even get to rationals, you have to know, okay, we have that the top of your fraction is your numerator, your bottom is the denominator. And lots of ways you can do that, you know. Back when I was a kid, they used to say D for denominator, D for down. Those are the bottom part. So that's one way you can do it. So rational numbers be written a couple different ways. Okay, you can write it as a division. Okay, and you get 3 divided by 2. Be written and used as a part of a proportion. Joe received 1/2 of Mary's salary. That's a rational number. They use rational numbers in ratios. Okay, the ratio of Republicans to Democrats is 3 to 5. Okay, it can be used as a probability in using a fair coin, and that happens to be chapter 8 or chapter 9. Excuse me. All right, so ways you can model rational numbers. You have the area model, which is these are all the same. Or actually, these aren't all the same. There's another one. You have 2/3 here. Okay, you have 2/3 on a number line. It's 2 of the 3 are shaded, and then here you have 3/5 using set model. Okay, it says to understand the meaning of any fraction A over B, B cannot be 0, and what we're using is parts to the whole model. Okay, and how do I deal parts to the whole? Well, you got to know what the whole in the question is. Okay, and the number B of equal size parts, which the whole has been divided. Okay, so if I have a whole, which is 1, B is how many times that the whole is divided up in equal pieces. And then A is the number of parts of that whole that you're going to select. Okay. All right, so proper fractions, and this is a big thing for me. Okay, what makes something a fraction and a proper fraction? Okay, a proper fraction is a number in which the numerator is smaller than the denominator. Okay, that's what this all says. Okay, 5/8, -2/3. These are both proper fractions. We sometimes misrepresent what a fraction is because we have proper fractions and improper fractions. An improper fraction is in which the numerator is bigger than the denominator. 8/5, -3/2. The top is bigger than the bottom. And one thing that as a teacher, I don't want you to do is just call everything a fraction. Start getting used to saying proper fraction and improper fraction. It'll help the student out longer. It says what numbers are represented on the number line. Okay, so this is 2, right? And it's divided up into 1, 2, 3, 4, 5, 6, 7, 8 spots. Okay, which means we should get these numbers halfway between -2 and 0 is going to be -1. Halfway here is going to be 1. 0 to 1 is 4 spots, so 3 of them makes 3/4. Here's 7/4, and so forth. Okay, equivalent fractions. These are fractions that are the same. Okay, so now how do I know they're the same? Well, but all these have the same size, and notice this is divided in thirds, or 3, and 1 is shaded, so it's 1/3. This one's divided, same size, divided in 6 pieces, and it's the same amount that shade it has, and it takes up 2, so it's 2/6. And then this one's divided into 12 pieces with the same size shade, and there's 4 pieces in the shade, so 4/12. Because they're all the same size, the shade's the same, that means all these equivalents, our fractions are equivalent, or the same. So 1/3, 2/3, 2/6, and 4/12 are all the same fraction, where 3 1/3. This one here would be the reduced form. Now, one of the things I was going to be able to show you this year, and I didn't have it with me now because it's stuck at my high school, is I had found these fraction strips that we could have been able to use a little bit. But, you know, if you take this as a whole, and if I need to divvy up in 2 equal pieces, that means these would be both halves. If I can give you pieces that 6 equal pieces can make up this whole, that means each piece would be 1/6, and each of these 1/12 would be the same. Okay. Some of the rules for fractions: if I have a fraction or a rational number, and I multiply the same number top and bottom, then the number is going to stay the same. Okay. Now, how do I find a missing value or into equivalent fractions? Now, these two fractions are said to be equal. That's why I have the equal sign. So 12 over 42 would be the same as x over 210. What would x have to be to make those equal? Okay, and there's a couple different ways you can do this. One, you can see what multiplies 42 times what gives you 210, and then multiply the top by that same number. So notice 42 times 5 is 210. So if I multiply the top by 5, I get 60. 60 over 210 would be the same value, which means x has to be 60. Okay, there are different ways you can do this. Okay, when you get into algebra, you're going to cross multiply and divide. That's something that you're going to get farther into it. Okay, now this number here could have been reduced. Okay, so if I look at something like that, differently. Try this again here. Okay, we could have said this, and this reduces by, oh, it looks like 6. So that's a 2, and this would be a 7. And then I know what times 7 would give me 210, which would be 30. So 2 times 30 is 60. So again, it does work. All right. There we go. All right, so a rational number A over B is in simplest form or lowest form if and only if the greatest common divisor is 1. In other words, you can't take anything else other than 1 out of both top and bottom, then it's reduced. Okay. Now, how some other ways we can put things in simplest forms? Okay. So if we look here at A here, let me kind of get my drawing thing again here. Let's go red. All right, how can I reduce this? Well, let's take the coefficients first. Well, 28 and 42 both have a 7 in common. Okay, so I can take, this would be a 6, and this would be a 4. And then 2, I can still take another 2 out. So that's going to be a 2 and a 3. So already I know this is going to be 2 over 3. And then I can reduce letters. There's 1A here, 2 of them on the bottom, which means I have an A on the bottom. And then these B squared and B squares cancel, which gives me 2 over 3A. Okay? So how do I deal with B? Well, remember, A plus B squared, it just means A plus B times A plus B. But this, if I take a 3 out, or factor out a 3, I have A plus B, which is the same as this A plus B that I have 2 of them for. So I get 2 of those, I get that one there, which leaves me with A plus B all over 3. And then finally, in C I have a GCF, so I take out an X times X plus 1 all over X plus 1. And those cancel, which leaves me with X. Okay? So different ways you can deal with these. All right. Okay, now this is a different way of showing it. Showing you how this all works. Yep. So different ways of looking at them also. Okay, now let's look at this one. Okay, so we got a couple more. So notice 3 plus x squared. There's nothing in common here, so this does not reduce. This 3x, that's not supposed to be there. Okay, these 3 cannot cancel because I have this x here. These x squares cannot cancel. So this is my final answer. However, if I have everything has a 3, I can actually count that 3 out, 1, this 3 will be a 1, that 3 will be a 1, which actually gives me 1 plus x squared all over x squared. Now, because this x squared up here has a plus sign with a 1 in front of it, these cannot cancel, which means that can't be simplified, and then that is what we just came up with, and we got that final answer. All right. So let's look at this one. How do I show that something is equivalent is what it's asking for. Okay, so if I want to say, how are these equivalent? Well, there's a couple ways you can do. You can reduce both of them and see if they end the same fraction. You can cross multiply and see if you get the same numbers. Okay, so one method, simplify both fractions in the same simplest form. Okay, so I can simplify 12 over 42. I can reduce it down to 2/7, and I can take 10 over 35, take out a 5 on the top and bottom, and I get 2/7, which means they make them equivalent. One way to show it. Another method, rewrite both fractions with the same least common denominator. I'm not a big fan of this one because if you look at the least common denominator, multiple would be 210, which means you'd have to write this one as a 210, this one as a 210, and those end up with the same value. Okay, now that's going to come in handy in a little bit. I just don't use it very often. Okay. Third method, rewrite both fractions with a common denominator. Okay. Now, this one, common denominator, common multiple at 1470, definitely not the best way to do things, but it does work. Easiest way to do that is multiply both denominators together. And the 12 over 42, since I had to multiply 42 by 35, I multiplied 12 by 35. And the second one, I multiply by 42, so 10 times 42 is 420. And then you look at the two fractions, are they equal? Yes. And the other method is by seeing if they multiply, okay? Now, I like to show this one a little bit differently because those numbers get a little bit big, okay? So let's kind of show you this real quick. Let's just say I have 4/6 is equal to 2/3. Now, what this fraction says they're going to be equal is if I cross multiply, I get 12 is equal to 12. Check, and that means these two are equivalent. If I did 4/5 equal to 2/3 and I cross multiply, I would get 12 is equal to 10, which is not true, which means these are not equivalent. Okay, that's another way to tell equivalency. All right. Okay, now ordering. We're going to talk about ordering here a second. Let's kind of get to that. Find two fractions that are between 7/18 and 1/12, or 1/2, excuse me. So easiest way to do that, okay, is by trying to get these guys the same fraction. Well, the easiest thing to do is make this into 18 by multiplying by 9. So 7/18 and 1/2 would be 9/18. Can you find one number that's in between those? 8/18 would be between. And then you could also find another number, which if this simplifies, take a 2 out, that'd be 4/9. That would be another one that would work under it. Okay, so you can do a couple things like that. All right. Okay, so now find two fractions equal to 7/18 and 1/12. Easiest way to do that is just multiply numbers. Like if I can multiply top and bottom here by 2, you can multiply the top and bottom here by 5, you'll get equivalent fractions. They're the same. Okay. And we don't really need that one. So that pretty much is 1.2.